Hello out there in remote learning land. Last couple days we've been talking about air masses and fronts and how that affects the weather. Well, today we're going to talk about what happens when fronts get together and how that affects weather across the United States. It creates this pretty wild phenomenon. We call it a mid-latitude cyclone. And it really gets interesting at different parts of the year, but it also allows for very accurate weather forecasting because you can predict a lot of moves that these cyclones are going to make. All right, that's what we're chatting about today. And there it is. That's a mid-latitude cyclone. It's basically when a warm front and a cold front hook up here. And then they'll travel across the United States, normally to the northeast, because that's the way our planetary winds are going. All right. So let's jump into it. Take a look at this quick forecast. See if you can predict the weather based on these maps here.
This morning we had fog up around the Great Lakes. Many of the areas around Indiana, Illinois, and Wisconsin had some difficulties with the morning commute because of the fog. It has cleared out though, and we are facing rain now. As we talk about this rain, we're going to watch this system march across the country here and just push that rain south or eastward. It's going to trigger some storms across Texas. We're going to see most of this staying in the Midwest. We do have a low just off the coast here that's going to be pulling eastward, and it's going to take the rain with it that's across the mid-Atlantic. Stationary front over Florida continuing to bring rain to that section. Cold air settling into the west as well as into parts of Texas and Oklahoma. A bit windy here, and we're going to watch this cold front kind of shift south, and as it does that, it'll bring in some gusty winds. We'll have some mountain snow through the panhandle of Idaho and possibly the northern Rockies in Montana. Otherwise, it's rain in Seattle.
Okay, so hopefully you followed some of what she was saying there, and you could see how the different fronts were interacting across the United States. I hope you noticed that it was always raining at the fronts, right? That's a big connection there. So here we have a simpler map, right? Cold front in the northeast. You can see it's raining at that front. And a warm front down in the, that's the northwest. And a warm front down in the southeast here. And you can see it's raining a little bit ahead of that front, right? It rains directly at the cold front and a little ahead of a warm front. Okay. There's your cold, and of course there's your warm fronts labeled. A couple other cities that these fronts are going to be affecting in just a bit. Behind the cold front, you'll notice it's very calm. It's what they call stable conditions. This is in the continental polar air mass, and there's not much going on except a cold, sunny day. Okay? At the front, we say that it's unstable. It's rising air, low pressure. They call it unstable conditions. Okay? Again, behind this warm front, not much going on, right? Some more stable conditions. And of course, just ahead of it and at the front, it is unstable. And that's, again, rising air causing rain. Okay? So just a little notes for you to take on the bottom there. All right, let's keep moving. You'll notice that this front is going to initially head toward the southeast. And this one is going to head toward the northeast there. All right. And when they do, they'll often connect together. Now, I don't have that showing at this point. That's just the general motion that these fronts will take. Okay. Notice what happened here. D was having a very nice day. And as the cold front approaches, boom, the pressure is going to drop, and you're going to get a crazy storm right at D right now. With A, as the warm front approaches A, the clouds will start to get lower and lower, and you'll get your gentle rain until, of course, it gets there. And that's, showing you a transition of weather as it approaches each city here. All right. Those are your generic motions there, the arrows there. So please label the diagram in your notes as neatly and as best you can to kind of follow my progression here. All right. Next couple of hours, a front will hit, of course, D and A, right? That's what happens there. Generally, a cold front will move a lot faster. It's denser air, and it really barrels through, whereas the warm air, think of like a beach ball. It's much less dense, and it just kind of slowly moves along. Okay? All right. This kind of breaks it down step by step. With each little bullet point, you'll notice a change in the diagram, so please try to connect those two. All right, we start out with a stationary front, right? The cold air isn't advancing, the warm air isn't advancing. They're just kind of going side to side. And you can see the symbol there, right? The triangles are this way. The cold air wants to go there, but it's not yet. And the warm air wants to go that way, but again, it's not yet. So it's a stationary front. All right? Then you'll notice that a swirl begins to develop on opposite sides. As you move things this way, a friction is created. As the cold air rubs the warm air, a friction is created. It's going to start to twist it, and you'll see that in this picture here. But literally, that touching of the air starts to create this circular motion. And I don't know if you notice, but it's starting to spin which way? Counterclockwise, right? Low pressure in the United States spins counterclockwise. The cold, dry, more dense air begins to close in on the warm air. You're going to see it's going to start to chase the warm air. And that's what's going on here. It's literally starting to chase it. And now, of course, we have a cold front that officially formed and a warm front that officially formed. And the cold front is going to move faster and eventually catch it. The faster moving cold front will overtake that warm front, and you'll start to make what's called an occluded front. And you'll see the symbol change right there. As those two fronts come together, right now those symbols combine, and they call that the occluded front. All right, and there it is, just getting a little more developed, and you can totally see a counterclockwise swirl, and this has formed into what we call a mid-latitude cyclone. Okay, and there it is. The cold meets the warm. The worst part of the storm is where the two fronts touch. As it progresses, the cold will start to catch the warm, and then it'll start to make this occluded front. Okay, all right. This gives you a really cool side profile of it. So from A to B, you'll notice you're in the cold air, then you cross the occluded front, and then you go into this section here. And that's basically a top view of this side view, right? Here's the cold air, there's the occluded front, there's your warm front. That's what's going on as you go from A to B. Okay? In which direction will this pressure system move now? Well, the one front, the cold front, came from the northwest. The warm front came from the southeast, and now the two of them have a tendency to move out toward the northeast. All right, so let's develop this a little bit. There's your cold front, and we knew that because we have colder temperatures behind, right, in the 30s and 40s. In front, we have the 70s and 80s. These are warmer temperatures behind this line, so that must be your warm front. Put them together, and we call it a mid-latitude cyclone. Okay? Oftentimes at the top, you'll see that occluded front popping out there as the cold front catches the warm front. You'll see those two combine, right? Okay. Down here's your Gulf of Mexico. That's the source of warm, moist air, right? That would be maritime tropical air mass in there. Over here, coming from Canada, way up north, would be your colder, drier air. That's your CP, right? Okay. These conditions are going to be wet and warm, so these circles here are the weather stations, if you recall, and you need to be able to predict the weather at these stations based on where the fronts are and what's going to happen over the next few hours. All right? There's still cold air in front of that warm front there, so you can kind of start piecing these things in one part at a time. The lowest of the pressure is going to be where the fronts come together, okay? And, of course, it's going to spin counterclockwise, right? Low pressure in the northern hemisphere spins counterclockwise as it moves toward the northeast. You'll have all heavy rain along the cold front. You'll have gentle rain at and ahead of the warm front. And the occluded front, you would also have precipitation. Okay? And this just gives you some points what we just talked about. Make sure that you read them through, get them in your notes. All right. Cold fronts, remember, those are the ones you can get your crazy thunderstorms because the warm air rises very quickly. It's extremely unstable. Okay. All right. This is, again, going through, right, looking for a profile. Take a look at the top right there. So we start in the CP, the Continental Polar Air Mass. That's right here, point X. Then we go until we hit the cold front. That's right there. Then we end up in between here in this warmer maritime tropical air. That's right there. Then we cut through the warm front, which was right at that point, and we end up in the cooler air on the other side. Top view, side view, right? We call that a profile view there. And there it is, the CP air mass, the MT air mass, right? The warm front, and again, the CP air mass. Okay, all low pressure systems move toward the northeast in the United States. So I'm going to attach this map to the GC, and we'll crank on that map. And in the meantime, of course, you guys have some summary questions as well. All right, take your time on it. We'll meet you back in the GC, and we'll go through it.